Hello do-it-yourselfers, Terry Peterman, the internet electrician. In today's project video, we're going to take on the wiring of this greenhouse. We're going to put in a light, a couple receptacles, something to plug a heater into, and a cooling fan. So let's get started. Alright, so here's how we're going to feed the power to this greenhouse. Now if you watched my landscape lighting video, project video, you'll see how I supplied the power over here to this box. This is the switch for the landscape lighting, fed by that outdoor panel over there. And then out of the back of this into the greenhouse. So if you haven't watched that landscape lighting video, it's going to be in the same playlist as this one, so you're going to want to check that out, and we'll put a link in the description. So there's the feed coming in. That's as far as I got with the greenhouse. As this conduit goes into a back of a PVC box inside the greenhouse, and we'll take it from there. Okay, so here we are inside the greenhouse. Here is that PVC box that I ran into the back of. Got my hot, my neutral capped off because they're hot right now, and my ground wire. So what I've got a piece of can truss or 2H unistrut mounted here between the structure, the wall structure of the greenhouse, so that's nice and solid. And what I'm going to do is add a double gang box right here. This double gang, in it is going to house a occupancy sensor, so it'll turn on that light that we're going to install when there's motion in here, and of course shut it off when there's nothing going on. Not often you're going to be in the greenhouse at night, but however we're going to put a light in, and as I say, so that you don't leave it on, we'll do an occupancy sensor on that. Then we're going to come out of the top of this box. We're going to use liquid tight flex for this because we've got all kinds of bends to do, so not so easy to bend PVC pipe. A little easier with EMT or something like that, but we're using PVC, so I'm going to use liquid tight flex. Liquid tight in that we're doing this, it's really an indoor project, but it's kind of indoor outdoor because there will be a lot of water around here, so we're going to do our best to make sure that everything is semi-waterproof, and we're going to feed it all with a GFI receptacle that I'm going to install here. So we're going to be GFI protected, but yet we're going to kind of treat it as a damp location, and we'll wire it as such. So as I said, then out of here we're going to come up with liquid tight flex. We're going to put a octagon box on the ceiling in the middle strut there, to which I'm just putting a simple keyless lamp holder, and I'm going to put a simple LED light bulb in it. Can be a low wattage one, 60 watt equivalent. I'm going to put a guard on it just in case you whack your head on it, although I don't have that problem when I'm only 5'8", soaking wet. So not a problem for me, but we'll put that light guard on there just in case. And then we're going to go on to a outlet box on the far strut, and that's to plug a fan in. And now I've kind of rigged up a old floor fan here that the guard broke off, so I'm actually using that just to help exhaust the heat out of this greenhouse when it gets hot. So that's going to be a box up there that's going to be switched, and that ceiling fan is going to plug into. Now I say switched, it's going to be controlled by temperature. So let's get into this temperature device here. Now this is what you call overkill. This is something I had left over when I worked in the oil field. So this is actually an explosion proof temperature control device. So way overkill, but I had it, so I'm going to use it. I tend to keep things around and find a use for them down the road, and here I am probably 20 years later using it. So right now, as you can see, it's kind of hot in here, so you'll have to excuse me. It's 34.9 degrees Celsius, which is almost 95 Fahrenheit for my American friends. So this temperature device has got a normally open and a normally closed contact. So I'm going to set it up so that when the temperature rises, it's going to close the contact, and it's going to turn on that ceiling fan to help exhaust the hot air. And when the temperature falls, I'm going to have another receptacle hooked up here for a heater, a space heater that'll be in here for those shoulder seasons when it gets cool at night. So what that'll do for me is somewhere around 30 degrees Celsius or 80 some degrees Fahrenheit. It's going to trigger. I'll have to do some calibrating of that, and it's going to turn on that ceiling fan to help the cooling effect. And then as the temperature cools, it's going to shut off that ceiling fan, and the contacts will close to enable a heater. So we could have that heater controlled when we're gone, but normally drops below a certain temperature, we're going to have it so this outlet is live and that heater can work. But we never want both working at the same time, which would be just silly. Heating up the air in here and then shooting it out with the exhaust. So there's not a whole lot of dead band on this switch, but we'll find out when we get to hooking it up. So enough of me rambling on. Let's get into the wiring project. Got to go PVC from this box into this box and out to the temperature switch. I'll show you all that when I've got them mounted. And then out of here with liquid tight flex, like I said, going up to the ceiling box, and then out of that to the receptacle for the fan. So let's get at it. I'll do some wiring here, show you as many steps along the way as I can. So I'm going to show you how these spring nuts work inside this can truss or unistrut, different brand names. But basically a spring nut is a nut with a spring. So you push it inside the track and turn it, and then use a 1/4" bolt to screw your box on. So, or anything on there, conduit straps, cable straps, tech straps, whatever you're gonna mount to that. So put those in, and then I'm gonna mount my box to those spring nuts. I'm gonna put a connector here, connector there. I'm gonna have to drill a hole in the side of each of these, measure it so it's level, and then cut a little piece of PVC to go between there, and do the same on this side. So we'll start by mounting this box just loosely for now and get some rough measurements, and then we'll drill our holes for the conduit and measure the piece we need. Okay, and so you see with this box works quite well because you can tighten that and it's bearing on the top of the can truss here and there, so it sits nice and level. You see what I had to do with this temperature device? I had to put a washer in behind there. Otherwise this didn't reach the top of the can truss and it would have sucked in and been crooked. But as you can see now, it's nice and level and tight. So like I said, finish mounting this, measure my pieces, put my connectors in. Okay, so I've got my boxes all mounted, so I had to use a hole saw, a 1/2" conduit size hole saw drilled into the side of that box. Into this box I had to drill a hole on both sides of it as well. This side had a threaded, this temperature switch had a 1/2" NPT thread here, so I just threaded in a coupling connector here. These needed lock nuts, and to space it evenly, 1 3/4" piece of PVC here, 1 3/4" piece here, all evenly spaced. I ended up putting in a couple spacer bars in behind here just so that these tabs had something to snugly tighten down to. So there's all the devices mounted. Now we're going to come up out of here with some PVC conduit to a female adapter, and then we're going to start with our flex once we hit the corner up there. So I'll show you that in a minute. Now just to I mean, most people aren't going to have any can truss or unistrut laying around. You can get it at the electrical wholesalers and the spring nuts, but if you didn't have that laying around like I did, makes a nice industrial looking job. But you could also just put a piece of 1x4 across between these two support structures and screw your boxes to it, or anything, a piece of plywood that fits. So that's just to not to say you got to do it my way, just that I had the stuff laying around, and you can do it with wood, so keep that in mind. So I've got my nipples all installed, ready to head on up to the light fixture box and on to the receptacle for the cooling fan. So I'll measure the conduit that I need to go between that double gang box and this female adapter here. You can see how these weather tight or liquid tight flex connectors work. 1/2" NPT threads here with a gasket. You can see that. So threading that on, and then they're gasketed here. And this whip, sometimes they call it. I just bought an air conditioning whip from Home Depot. They also sell this liquid tight flex in bulk lengths. But as you can see, you thread that down, makes a seal on that gasket. Now I just go measure the chunk of pipe I need between here and the double gang box. Okay, and there's my piece. Turned out to be 13.5 inches to go up, just so that this flex is going to make a nice gentle bend and come up and tie on to the unistrut that's just above it. Alright, so I got that piece cut. PVC going up into that female adapter. Then I got a flex connector screwed into that. Screwed my flex into the flex connector, and up it goes. And there I used a 2-hole strap And again, using spring nuts in my unistrut or can truss there for a 2-hole PVC strap. Then I turn the corner and head towards the light outlet box. And I just used a PVC 2-hole strap on that cross member that goes across the top of the gable here, or the metal truss. And I tell you, there's some things I don't show you, and that's because sometimes I swear a lot, because that was the hardest steel I've ever seen in my life. I started with self-tapping screws, broke them off, drilled, pre-drilled, still broke self-tapping screws, reamed it out a little bit because the next size bit was too big. Anyway, got those in. So I got 2 screws into that little beam across there. It's just about I don't know, 3/16 of an inch thick, but man, is that hard. Same thing over here where the octagon is mounted. I drilled 2 holes in the back of that box. Again, fought with 2 screws to get into that piece. Now I got to do it again on that far beam, which is going to be rigid now, rigid PVC between that octagon box and the last receptacle that's going to be for the fan. Okay, got that final receptacle box mounted. Those self-drilling screws, I should call them, not self-tapping. They went a little better this time, but we got them so the far ears of that box are screwed into that cross member. I'll show you that from the other side. Then I cut a piece of rigid PVC pipe that goes between the octagon box for the light and that last receptacle. Okay, so you can see I got the ears of that box just on that cross member and got those self-drilling screws in. Now a little tip on self-drilling screws: if you run into hard metal like I did, go on high speed until you feel the drill end of the screw starting to bite through, and when your threads start to bite, put it in low gear, put it in the lowest speed, and then just slowly turn it in until it bears down hard, and then back it off. Reverse a little bit, forward again a little bit, reverse a bit, and keep doing that until you get through. Save you a lot of grief, a lot of heartache, and a lot of profane language. So there you see it, that last chunk of rigid PVC to the octagon. I'm looking from this way backwards, coming down, and flip the camera over, coming down to our boxes on the wall. Now it's time to pull in some wire. Okay, so I've got my wires all pulled in. I'm going to draw you a schematic on my little whiteboard to show you exactly how these connections are going to be made, and I'll try to use the right colors that I've used here. But what we have here now is power coming in, as we showed you before, my black, my neutral, my hot, my neutral, and my ground. So we're going to have a GFI here. Then we're going to feed the load side from the GFI. So line side on the GFI with the incoming power. Load side here. Coming over here, we're going to feed the occupancy sensor with power. We're also going to splice that black wire over to my temperature switch, to the common on the temperature switch over here. There's a common, a normally open, normally closed. Neutrals through everywhere, of course, grounds through everywhere. Then out of the temperature switch, we're going to have a red wire that's going to come over here and feed the receptacle. That's going to be the heating receptacle. So whenever the temperature is below a certain temperature, that'll make this receptacle that's going to be here live, and you can plug a heater into it, and you can heat this up if you need to in the shoulder seasons. And then on the other side of that switch, common, normally open, normally closed, the normally closed here is going to be the cooling. So I labeled that one, or taped it, identified it blue. That'll be on the normally closed contact. So that blue wire is going to just come through from here, go up through the conduit, through the light outlet, and over to the receptacle for the cooling fan. Then I've got so I've covered the heating, the cooling, the power on the load side of the GFI, for the occupancy sensor, for the common of this. And then here off the occupancy sensor, the switched side of that, I labeled, or I identified it yellow, and it goes up to the light outlet box, again along with the neutral and a ground, and that blue wire for the cooling fan receptacle. So Again, everything gets a ground wire. Let me show you up in the ceiling here. Okay, working our way backwards now. That's going to be the receptacle where the cooling fan plugs in. So you see my blue wire, one identified as blue, hot, neutral, and ground in that box, ready to put a receptacle on. Then we're working back here, back to the light outlet box. And there I've got that yellow wire. That's going to be for the light coming off the occupancy sensor. And then we have neutral, ground again, everywhere. And then out of that, the flex coming back down to that double gang box I showed you. So again, we'll show you this all on the whiteboard. All right, so just to help you understand the connections a little bit better, I've kind of drawn it out on the grease board here. I've left out neutrals and grounds because neutrals, the receptacles need neutrals, the occupancy sensor does not in this case, but the light does, and the receptacle for the cooling fan do. So we'll leave them out just so we can follow the current flow. Here's our line in that comes into the back of this first box, goes to the line side of the GFCI receptacle, out of the load side of the GFCI receptacle so that everything in the greenhouse is protected by ground fault circuitry, out of the load side to the occupancy sensor box at 2 gang. Here we pigtail. One hot wire is going to go to the occupancy sensor line side. One hot is going to splice through to the common of the temperature switch. And then from here, in the temperature switch, the normally open, that's that wire that I identified as blue, the normally open is going to go out, back over to the 2 gang box, up through the flex, through the light outlet, over to the receptacle for the cooling fan to plug into and hook to the hot side of that receptacle. On the normally closed side of this temperature device is that red wire. It goes back over here to the 2 gang, feeds the hot side of this receptacle where we'll plug in a heater. Occupancy sensor, like I said, gets a hot wire, and then the switch side, the output, is the one I identified as yellow. That's going to go out to the light. Okay, so that simple keyless light fixture there. So to explain the temperature device a little bit, this, when a temperature rises, that goes up, touches the normally open, and that turns on the receptacle to allow the cooling fan to exhaust some of that heat. When it cools, it drops down, hits this normally closed contact, which is the red wire. That powers up this receptacle where we can plug in a heater, so that heater will only work when the temperature is below where we want it to be, and above, the cooling fan will run. Occupancy sensor senses somebody's in the greenhouse, turns on that light, and you can adjust this so that ambient light, you can set it to different levels of ambient light required, how long you want it to stay on when there's occupancy in the room, etc. So there you go, with only the hot wires shown, ground fault, GFI, occupancy sensor, heater receptacle, the temperature switch, the light outlet, and the receptacle that the cooling fan will plug into. All right, so we're ready to start hooking up devices. We're going to start backwards now. So the end of this circuit, which is that receptacle that will be for the fan, we're going to hook up our receptacle here. So always a good idea to start at the end and work your way back, and that way you can just, when you get to your final connections, you can turn on the power, check everything out. So I'm stripping my conductors and giving them the hook for the receptacle. My ground here, I'll give it a hook. Hopefully you can see this. It's so bright in the greenhouse I can't see the monitor, but I think I've got it set. So you got a close-up of the box. So we're going to go around that ground screw. Tighten that up clockwise around that terminal. So you get a nice even tightening. And now I'm ready to hook up my receptacle. I like to use a cordless drill for this. So push those guys out of the way. When hooking things up, I like to always go ground, neutral, and then hot last. And vice versa when disconnecting devices. Unhook your ground, unhook your neutral, and then unhook your hot. So ground wire, neutral, Same side. Don't over tighten it. Always a good idea to spin in the unused terminal screw, especially when using a metal box. So you can bump the device and knock that backed out screw terminal onto the side of the metal box, cause a short circuit. Okay, ready to install the device into the box. Push your wires all in nicely, make sure nothing's pinched, and get one screw started and the other one, and then you can push it in and finish tightening your screws. That one seems to have bottomed out, so I'm going to have to shorten that. That box screw, that must not have been tapped. Deep enough. So I'm going to just get my small bolt cutter on my other stripper and just trim that screw off. So I grabbed my tool here that has a bolt cutter on them, and a lot of people don't even know what that is for. That's included on a stripping tool. This particular device or tool is from Crocs. You can check out one of my videos. I reviewed these for them a few years back. But you look at the hole, that's a 632 machine screw hole, and you thread your machine screw in. I'm going to cut about half of it off. Cut it. And now when you back that out, it chases the thread so you don't have a bad thread. That's better. Now it's tightening down fully. And now we're ready for the plate. Now I checked the code, anything I could find about greenhouses. Seems to be a lot of ambiguity as to how you wire a greenhouse, and most of the stuff I found was on a commercial greenhouse. For all intents and purposes, probably doesn't apply to a backyard greenhouse such as this. But anyway, I wired it pretty much as a wet location. I could put weatherproof covers on everything, but it really matters as to if you think you're going to be spraying the garden hose all around in here, or if you're just going to be watering the plants. So basically it's just a warm location, high humidity, but basically dry. So I think with my PVC glued fittings and all plastic pipe, we're not going to have any issues with corrosion, nor with getting electrocuted. The floor in here is wooden, and I've also got a tile base, click together plastic tile base on it. So there's really nothing that you could probably get a shock against. I guess the structure is metal, but my device boxes are all grounded, and it's all protected by a ground fault circuit interrupter. So there's that one ready. I'm going to unplug and get my fan in here and ready to go once the power is restored. Should do something nice with this cord, probably wrap it up with some tie wraps. Actually, I've left a little bit of a perforated strapping piece here that is supporting my fan. I'll show you a picture of how I mounted this floor fan just for some amusement purposes. Reduce, reuse, and recycle, they say. Okay, ready to move on to the light outlet. Alright, so here we are at the light outlet. I just re-watched that last segment and I said something backwards when I said when I like to disconnect devices, I like to do it opposite, and then I proceeded to say it the same way. So when I disconnect a device, I like to disconnect the hot first, then the neutral, and then the ground. But I didn't want to redo the whole segment for that. Okay, so at the light outlet here, this plastic, we call them porcelain chandeliers, just a keyless lamp holder, no ground terminal on it, so it does not need a pigtail to tie on to the fixture at all plastic parts, and no terminal provided, no need for a tag of the grounding wire. So we just have to go around this box grounding terminal. Now our neutral's carrying through, So I do have 2 terminals for the neutral here. So I'm going to cut that. The wire that's heading off to the receptacle for the fan, which we identified as blue at each end, it's actually a black conductor. That just gets tucked up into the box, passing right on through to the receptacle. And here's my black that I identified as a yellow for the lights, just to keep things straight. Now we will strip everything. Now with that neutral wire, to keep it whole, I could have just stripped the length of it in the middle of the conductor here, stripped the insulation off of about an inch or so and wrapped it around one of the terminals. Then you know you're not going to get a bad connection. But you know, if you make your connections and you're careful with them and you make them good, they're not coming apart. That's why you do things right. And the terminals are designed for feed through, or they would not provide you terminals for that purpose, and they would get UL or CSA or any other accredited approval company, agency, wouldn't provide them with their approval ratings if they weren't approved to be used as they're designed. So I'm going to bring both those in on the same side. Snug them down nice and tight. Here's my neutrals. Neutral silver, hot brass. Brass is connected to the center pin of the lamp holder, neutral to the shell. Okay, now I just need to go get 2 832 screws, screw that to the box. I thought of using this. I was at the Home Depot and I saw LED keyless lamp fixtures all integrated into one. Nice LED fixture here. Does the same thing as this, only it was $30. This I believe was $2. Light bulb under $2. And the guard, so about $5 worth. And here's my fixture for the greenhouse. So I'll screw the bulb in, the lamp in, and put the guard on. Okay, so again, there's lots of times I have to turn the camera off because if you heard what I said about these little guards, I might get sued, or at the very least the video would be X-rated. Have to have a disclaimer and a warning on it because that was not fun. These guards are designed for old porcelain keyless fixtures that used to have a collar around them, and some have a collar on them. These new ones don't, so they send these little plastic hanging guards that go around the box screws. And things don't go together quite as good as they should. So if I was doing this again, would I put this guard on? Probably not, but I thought I better do it. Finish what I set out to do. Very little gain out of this because I doubt anybody's going to be hitting their head on this. But hey, someone taller than us may eventually live here and may find it useful. So there it is, the bulb installed and the plastic tough lamp guard around it. Okay, moving on to the next fixture, to the next device. Okay, here again, hoping you can see inside this box. It's so bright in here that I'm not sure the camera's going to pick up inside there, but if not, you're going to have to trust me with what I'm telling you. So this is a capillary tube, an oil-filled capillary tube that just basically the fluid expands or contracts with temperature rise and fall. So I've got the bulb sitting here beside my thermometer. And as the temperature rises, this little plunger goes up and hits the micro switch, which would make the cooling come on through the normally open contact. And then as it cools, it drops down and it'll open the normally open and close the normally closed contact. And that would be the heating that we're going to use for the heating receptacle. So basically just so that you can't have cooling and heating going on at the same time. And like I said, help me use up a temperature switch I've been hauling around with me for about 20 years. So I kind of get a good feeling when I finally put something to use after dragging it around for years. So here's how I'll hook this up. I'm going to put stake-on terminals on these. I'm going to put a stake-on the black, red, and blue, and the ground. Ground goes here, black goes to common. Normally, I guess it's actually normally closed is going to go to my cooling. Normally closed to my heating, normally open to my cooling. So normally open, like I said, as it rises, it'll push the switch, which it's in the raised position now, close the contact between common and normally open, turn on the cooling fan. As it cools, that'll drop down, and the normally closed will close, and that'll allow us to have a heater hooked up in here. So let's get those terminals on and get this hooked up. Okay, so there's my wires all connected. It's such hard to work inside there, I couldn't really get the camera in and my fingers to show you it up close, but you can see it now all connected. Blue to the normally closed, red to the normally open, black to the common, ground to ground. Here's how you adjust this switch. You see that? That plunger just goes up and down, so it'll shrink down as temperature drops. So you've got to hold that with one wrench and turn that bolt in with another to make your adjustment. So you just have to calibrate it, which I'll do after. Pretty rudimentary device really, but that's a micro switch. And there's the actuator that does the control of where you want that set point to be at. Okay, so we got the GoPro going as well, so we'll kind of swap between the cameras, whatever looks best for what I'm trying to do here and not have my fingers in the way. So right now what we're looking at is the middle box. So here's our incoming neutral, incoming hot. We're going to have to pigtail these two, and one tail will go to the occupancy sensor. Then we're going to take the neutral here. We have to pigtail to this neutral. No neutral needed over at the switch box, at the temperature control box. So we do need to pigtail this one though, and have a tail going over to this receptacle that goes to the heater receptacle, heater outlet. Then the grounds as well, we need to pigtail. We need to make sure we tag off on the box screw there. And we need to have a ground tag to the receptacle and to the occupancy sensor. Then here is the yellow switch leg out to the light from the occupancy sensor. So let's strip these wires and make our splices. All right, so to catch the box grounding terminal, I'm just going to wrap this long tail. It's coming from the light. I'm going to wrap it around that screw. Eliminate the need for one pigtail. Okay, that's nice and tight. Now we'll pigtail these grounds. So in this pigtail splice for the ground wires, we're going to have the one to the light, the one incoming ground, the one going over to the temperature switch, and then we need one for the receptacle, one for the occupancy sensor. So we're going to have five wires all together here. Cut them all off evenly. And then twist them. Make sure your ends are all even. We'll cut them off again if we have to. Kind of gently twist them together so they're all evenly twisted. No one rolling over, not one rolling over another. But now you want to go to the shortest one and cut them all off even. Then take a marette. Make sure your wire connector or your marette is rated for 5 number 14s, which these ones from Ideal are. Okay, so there's your ground wire splice with your 2 tails, one for the receptacle, one for the occupancy sensor. Now the neutrals. We need incoming neutral from the GFI on the load side, outgoing to the light and the receptacle above, and we need only one jumper here for the receptacle. So strip those 3. Get them all together so their ends are even. There you go. Those ends are already nice and even. I don't have to clip them again. Spin on your wire connector. Any splice should be as mechanically and electrically sound as the original conductor. So what that means is you should no more be able to pull that splice apart. It should be as strong as just trying to pull the wire apart itself. And electrically, it should be as conductive as if you hadn't made a splice. So that's the rule on splicing. And now our hot wires, they just get spliced through, off to the temperature switch, and a pigtail for the occupancy sensor. So we need a pigtail here as well. No need for a pigtail for the receptacle here because it's getting its power from the temperature device for the heater receptacle. Now we could split that receptacle if there was a shortage of receptacles in here, because then you can make one half of it hot all the time and the other half switched for the heater. But we're going to have a GFI receptacle right beside here for convenience, so I don't see any need to have 3 half duplexes available for convenience outlets. So we won't split that receptacle just to simplify things as well. Okay, let's work on the receptacle first. Now we're going to want to poke things into the back of the box here because we've got to have room for the receptacle and the occupancy sensor. So we can adjust those wires after and get them out of the way. So for our receptacle, here's our switched wire back from the temperature device. Put a curl on that. Our neutral. Put a curl on that. I don't know if you noticed, that's where the holes in these strippers, most strippers have them, and that's for bending the hoop in the wire. I've explained that on many of my other videos, but you might not have watched those, but you should have. And the ground for the receptacle. Again, I like to use my drill driver, but I might as well just use the screwdriver now. Not a lot of terminations to make here. Ground, neutral, screw in that other neutral. Flip it over. Red switched hot from the temperature device. And that one's ready. Now the occupancy sensor. Okay, so for the occupancy sensor, they just have those push-in terminals. Not push-in, but you don't need to curl them around the terminal. You just have to strip the right amount on the back of this and push them in, and I'll show you how to do that. So the strip gauge, of course the ground doesn't matter. No neutral required on this occupancy sensor, but you do have to have a ground connection because they kind of cheat inside this device and use that ground for a little bit of trickle current just to run the electronics. So they do use the ground. You have to have one or it will not function. So strip the yellow. Check it with your gauge. Yeah, that's good. Push our, yeah, one we identified as yellow. It's really a black, but, and that's on the terminal. That's red here. That's the switched leg out to the light. Make sure your terminal, your wire is right in behind the wire clamps there, and tighten that nicely. Catch our ground wire, shove that straight in, snugly tighten that, and now our hot. Make sure you don't tighten the terminal down on the insulation of the conductor. Make sure it's on the bare copper. That's the reason for the strip gauge, so you get that right, and that you don't have too much bare wire hanging out at the bottom of the terminal. Because if you push that back in the box, and if you had too much wire stripped there, too much insulation, you could push that back onto a ground wire and cause a short circuit. So let's poke all these back in and put the device screws in, put a plate on. Okay, so I got the occupancy sensor installed. I did it first because there is not a lot of room in here. So you want to make sure all your splices are carefully tucked out of the way, so that when you tighten this is a big body on this occupancy sensor, so you don't want it pinching any wires back there. So I was very careful. A few test fits. I took it out a couple times just to make sure nothing was being pinched back in there. And then with this receptacle, there's a lot more room to work with, so that's what I'm going to put in last. Poke all your spare wires back out of the way. Push it in before you tighten the screws to make sure it goes in unencumbered. Now start your box screws, device screws. And again, like I say, push it, make sure it moves in freely and that your screws aren't driving it in tight against a conductor back there. Okay, now it's ready for the plate, but I'm not going to put that on yet because you have to do some adjusting of your occupancy sensor, and that happens underneath this plate here. So we won't put the plate on just yet. Now we'll move over to the GFCI. GFCI, going to be our hot wires in to the line side and load side outgoing. We have to take this ground wire, wrap it around the box screw. Oh, the whole thing fell out. It's just sitting there. It'll be held in place once the GFI receptacle is in. The device screws will hold that little bonding strap in place. And I don't like the way that the wires aren't wrapped tightly around that screw, so I'm going to get some needle nose pliers here and bend that in. Or I'll try again with my strippers, I guess. You want it wrapped completely around that screw without doubling back on itself, so you get maximum contact. Okay, get that ground wire out of the way because again, the GFI is a fairly big body. And you don't want it pushing against that ground wire. Now we gotta splice and pigtail these. Very difficult to give you good angles all the time here and good tight shots of this because I'm in the way. I'm working over top of some tomato plants. This is an active production greenhouse here, Sandy's garden. Okay, ready for the GFI. Okay, here's my GFI ready to go. Same backfeed terminals on this. Little yellow warning saying don't use these terminals if you're not using it as a feed through GFI, but we are, so off that goes. Ground first. Neutral, load side. So right now that's the top, which is going to end up being the bottom once I flip it. Don't forget that, because you never want to mix up your line and load or your GFI will just nuisance trip. It won't reset. And always make sure you check the labeling at the back of the device, because even Replacing a GFI with another GFI, different manufacturers may have line and load on top or bottom. Okay, cut my incoming line neutral. Back that screw off. Now you see, I stripped that one a little bit long, so we're going to nip that off a little bit. You don't want any bare wire hanging out the back of the device. All right, now we flip the GFI over. Now remember, load is now on the bottom, line on top. So always make sure you pair them up correctly. So we'll do the load first. Trim a little of this off, doesn't need to be quite that long. Load on the bottom. And my line on top. Okay, we'll put that one, poke the wires into the back of the box, and put in the device screws, and we can cover that one up with the plate. Okay, so here's an issue I've come across before. This type of PVC box doesn't have a feed-through hole for your box screws, or your plate screws I should say. So a lot of times they'll bottom out before they can turn in completely. So what I do is I take a little drill bit smaller than the threads that are tapped to 632 on here and here. I take a smaller bit and run in there just so that the screws don't get bottomed out and strip on you when you go to put your plate on. On this box beside here, it's not an issue because your device mounting posts come out a little ways away from the back here, so there's room for those plate screws to thread in nice and tight. So now I can go turn on the breaker and see if our GFCI will reset, and then we can start testing. All right, so we're back here. We're gonna reset. See the green lights on that GFI. Test. Reset. Okay, now we can start testing things. All that's left now is do a little testing. Put in my GFI plug tester. Hard to see in this bright light, but the proper two lights are lit, saying it's wired correctly. Push the button and the GFI trips. Also, you can do your reset and test here. Motion sensor, occupancy sensor. I've left that at a generic setting, and we'll have to see how that works. You have to take the plate off and pop this off to adjust it, and you adjust, of course, the sensitivity of the motion and how much ambient light before it'll turn on the light. And you could turn it on manually at any time by just pushing the button. My heating receptacle will not be on now because I've got the temperature switch adjusted so that the cooling will come on at 30 degrees. I adjusted that with these two little wrenches, and right now we're at 32 Celsius, so the fan's on. The receptacle for the heating won't be on, so I'll have to test that when that temperature drops below 30 and make sure that receptacle works, and that when you push the test button that the GFI will also trip. Okay, and up on the ceiling, the receptacle for the cooling fan. Plug in my tester. It says it's wired correctly, trust me. Trip. Fan goes off. The entire greenhouse is out. And we go reset that. And the fan comes back on. And you can see my fan here. My reduce, reuse, recycle fan that I salvaged instead of throwing it away when the guard quit. Broke apart, and I just took the base off, mounted it on the on the support structure there and hung it by some perforated strapping. And it's up high enough that it's not going to give you a haircut when you come into the greenhouse. And we just check our light. It's on right now, and I can manually shut that off with the occupancy sensor. So just to summarize here again, there's the devices on the wall, temperature device, my receptacle for the heater, the occupancy sensor, the GFI that feeds everything, and then we follow it up. Transitioning to liquid tight flex here. We're going to get awful bright looking into the sun. Follow that flex around into the light fixture and then on to the receptacle for the exhaust fan. Well, there you go, another completed project. Thanks again for watching. Please don't forget to like this video, subscribe to my channel. There's a whole ton of information here for you to help you do things both safely and competently. So like, subscribe, click the bell, so that way you'll know when I release a new video. Thanks again, Terry Peterman, your internet electrician.